Hello everyone, in this video I'll be explaining you the problem weird algorithm, and it's from CSES problem set, and it's an introductory problems. So let's set out the problem. Consider an algorithm that takes an input positive integer n. If n is even, the algorithm divides it by 2. If n is odd, the algorithm multiplies it by 3 and adds 1. Okay, the algorithm repeats this until n is 1. For example, the sequence n is equal to 3 is following this thing, because since n is 3, which is odd, so we are multiplying it by 3 and adding 1. So it's like 9 plus 1, which is 10, correct? Now here we have 10, which is even. Now we have to divide it by 2, so which is 5. If it is again odd, so multiply it by 3, which is 15, add 1 plus 1, 16. Now from here on it is going, 16 is even, so divided by 2, 8, which is even, divided by 2, 4, divided by 2, divided by 2, 1, and we have to stop it. So okay, your task is to simulate the execution of algorithm for a given value of n. So yeah, whatever value they are given, so we'll have to print all these steps. Input, we have only a integer, like we have only integer n, and we have to print a line that contains all values of n during the algorithm. So algorithm, whatever value it prints, whatever value it gets, we have to print it. So let's go to the board and see how to solve this. So so first example is n is given as 3, and in the problem what they've said is they'll give value n. It is a positive integer. They've asked us if n is even. If it is even, then divide n by 2. N will be n divided by 2. If n is odd, so your n is going to be n into 3. 3 times you have multiply by n and then add 1. Okay, so your n is going to be this thing, and for a given value of n, we have to do these two operations, operation 1 and operation 2, until n equals to 1. When n is equal to 1, we have to stop. Okay, so for a given value of n, we have to do these two operations. So whatever value we are getting, that we have to print it, and when n is 1, we have to stop it. So this is the question they've asked. Now let's try to find it here. So first they've given n is 3. So let me write here print. So 3 I'll be printing, because 3 they have given initially, so I'll print it, because all values are n, we'll have to print. So whatever n value they'll give, so in this print statement you will have the first n, and in the last you will have 1, because whenever 1 is there you have to print it and then stop. Okay, now since n is odd, n equals to 3, right? Since it is odd, your n is going to be n into 3 plus 1. So what is it? 3 into 3 is 9 plus 1 is 10. So now 10 you will be printing, and now your n is 10, which means it is even. If it is even, your n is going to be n by 2, which is 10 by 2, which is 5, right? So next 5 you will have to print. Now next n what you have got is 5, which is odd. If it is odd, you will have to make n is equal to n into 3 plus 1. So 5 into 3 is going to be 15, plus 1 is 16. Okay, 16 you will be printing, and now n is 16, so it's like even. Now your n is going to be n by 2, okay, which is 8. Again 8 you have got, so 8 you will be printing. Now since n is 8, it is even, and now what you have to do is, again when it is even, n by 2 you have to do, which is 4. So 4 you will be printing, your n is 4, and which is even. Now again n will be n by 2, which is 2. Okay, if you place n is equal to 4 here, so 4 by 2 is 2. Now 2 you will be printing, your n is now 2, which is again even. Now divide n is equal to n by 2, which is going to be 1. You have printed 1, and since n is equal to 1, you have to stop, right? So this is a simulation of the algorithm, and whatever values you're getting, you'll have to just print it. And one thing I'll this is like simulation problem, like it's not like rocket science. So but one thing I just want to make sure clear, I mean you just need to observe, is that if whenever you get n as power of 2, whenever you get n as power of 2, so from there on you will not get any odd number except 1. At the end you will get 1, because whenever this is like 2 power 4, right? So when it is 2 power 4, you are dividing it by 2, which means it is getting 2 power 3. So which is this 2 power 3. Okay, now again you will divide by 2, it is going to be 2 power 2, which is this. Okay, 2 power 2, now you divide it by 2, so it is going to be 2 power 1, which is 1, this thing. Now divided by this thing, 2 power 1 by 2, if you do, which is 1, so it is like 2 power 0. So in the algorithm, whenever n value is kind of 2 power of 2, so from there on you will not get any odd number, you will get only even number except the last one. So this is one of the observations that I wanted to let you know. But apart from this, it's very easy. So let me write the pseudo code for it. I think you understood, right, why we will not get odd number in case of 2 power. Let's say you're getting 2 power k something. Okay, so when you're dividing by 2, it's like 2 power k, and if this 2 goes up, it will be into 2 power minus 1, right? It's like 2 power 1, 2 into minus 1. So according to mathematics, if powers are same, sorry, if base are same, powers can be added. So it will be 2 power minus 1. K plus of minus 1 is this. So it's like 2 power minus 1. So again, 2 power minus, I mean, if it is 2 power of something, so it will be even number only. So that's the reason. So our pseudo code will be, we'll have to take while loop or something like that till n is greater than 1. If it is greater than, then you'll have to do it. First thing first, we'll have to print n. Okay, print n, and now you'll have to check if n modulo 2 equals to 1, which means it is odd. If it is odd, your n is going to be n into 3 plus 1, else it is even, so your n is going to be n by 2. Okay, you will have to do until n is greater than 1. When n is equals to 1, so we will come out of the loop. So 1 you have not printed, so at the end we will have to print 1 as well. You can print n or 1, because n will be 1 only, so you can print this, and yeah, this will be your pseudocode. Let's try to code it up. Let's see the input. In input we have we don't have test case, we have just integer n. So let's remove this test case, or we can comment it out. So I'm just calling solve function once. So I have n here. Now yeah, only n is given in the input, so we'll have to print these things. So first thing first, what we'll have to do is, if n is greater than 1, we are moving into the loop, we have to first print n, and it is separated by space. This is fine. Now we'll have to check if n modulo 2 1. So 1 means it's like true statement, so I'm not putting equals to 1. You can put this thing also, equals to 1, but yeah, let's make it less writable. So if n is odd, then your n is going to be n into 3 plus 1. Okay, else your n is going to be n by 2 as asked in the question. Now when you're coming out of the loop, you have to print 1, or your n value will be 1 only, so you can print n as well. Let's try to run it. Yeah, it is getting passed. Let's try to submit this in CSES problem set. Give me a second, let me log in. Yeah, I've logged in. So when you go to submit, task is this: submit. Let's try to choose the file. It is going to be CSES. Weird algorithm. Let's try to submit it. It is getting wrong answer. Let's try to see why it is. Okay, I got it. Why? Because see, in the algorithm, it may happen that your n is some large value, and when you are multiplying it by 3, so your n is going to be overflowing the integer limit. So in that case, you can take n as long. So this will work. Because of overflow, it did not get accepted. Let's try to submit one more time, wherein I've changed integer to long. Yeah, it got accepted. So yeah, long was the culprit. So in this way, you could have easily solved this problem. So it's easy only. Just one thing I just wanted to let you know, guys, is that whenever n is power of 2, so from there you don't you'll not get any odd numbers. You'll get only even numbers, except at the end you will get one, which is like stopping condition. So yeah, thank you guys for watching the video.